Welcome to another lesson of Math 0420 College Algebra. In this video, we will be discussing Section 3.3, Slope. In this section, we will consider computing a line slope, using slope to show that lines are parallel, and using slope to show that lines are perpendicular. Let's go ahead and get started with the definition of slope. Definition. Slope is the measure of the steepness of a line. Which compares vertical change which we call the rise, to horizontal change, which we call the run. Okay? The slope of the line through two distinct points, let's rewrite that. Our distinct points are x1, y1, and x2, y2. And it is the change in y divided by the change in x, which is equal to the rise divided by the run. And we compute it by taking y2 and subtracting y1 and dividing that by x2 minus x1. And this all happens where x1 or x2 minus x1 is not equal to 0 because we can't have division by 0. Let's try an example where we find the slope passing through 2 points. Example 1. We want to find the slope of the line passing through the points negative 3, 4 and negative 4, 2. Now it doesn't matter which one we choose as x1, y1 and which one we choose as x2, y2, but I'm going to let this first one be x1, y1, and the second one be x2, y2. So I'll take my y2 which is 2, and subtract my y1, which is 4, and then I'll take my x2. Remember, we have to stay with the same one, the same order, negative 4 minus my x1, which is a negative 3. So notice we have x2 and y2 first, and x1 and y1 second. As long as we have them in the same order, we're good. So 2 minus 4 is negative 2, and negative 4 minus a negative 3 is negative 4 plus 3, or negative 1. Negative 2 divided by negative 1 is 2. So the slope of the line that passes through these points is m equal to 2. Okay, let's do another. This time we have 4, negative 2, and negative 1, 5. So our slope, again, I'll start with the second point. So 5 for my y minus a negative 2 in the first point, divided by negative 1 minus 4. 5 minus a negative 2 is 5 plus 2, or 7. And negative 1 minus 4 is negative 5. So we get 7 over negative 5, which is the same as negative 7 over 5. So our slope is negative 7 over 5. Let's now talk about what the possibilities of slopes are for various graphs. So we have 4 different possibilities for values of the slope. We can have the slope be greater than 0, less than 0, equal to 0, or undefined. So if we have a positive slope, that means m is greater than 0, our line will rise from left to right. If we have negative slope, where m is less than 0, from left to right, our graph will fall. If there is 0 slope, meaning our m is equal to 0, then we have a horizontal line. There is no slope at all. And then finally, for undefined slope, the x never changes. So we get division by 0 in the denominator, and we have a vertical line. So again, the slope of a horizontal line is always 0, and the slope of a vertical line is always undefined. Positive slope rises from left to right. Negative slope falls from left to right. Let's do another example. Example 2. We want to find the slope of the line passing through six, 5, and 2, 5. Okay, so our slope m is 5 minus 5 over 2 minus 6. Well, 5 minus 5 is 0. 2 minus 6 is negative 4. 0 over negative 4 is just 0. So we have 0 slope. That means that we have a horizontal line in this case. Part B. Let's check the slope between these 2 points. 1, 6 and 1, 4. So m is equal to 4 minus 6 divided by 1 minus 1. That gives us negative 2 over 1 minus 1 is 0. So we have division by 0. Uh-oh. Whenever we get division by 0 for slope, that means that our slope is undefined. Which means that we have a vertical line. Let's now move on and talk about slope and parallel line. Slope and parallel lines. Definition. 2 lines that are non-intersecting are called parallel lines. So here are some properties that we get. If 2 non-vertical lines are parallel, then they have the same slope. Also, if 2 distinct non-vertical lines have the same slope, then they are parallel. And finally, for two distinct, meaning not the same or unique, two distinct vertical lines with undefined slope, the lines are parallel. So in other words, if two lines have the same slope and they're distinct and they're non-vertical, then they're parallel, and vice versa. Let's now show that a line going through 2 points is parallel to a line going through two other points. Example 3. Show that the line passing through 4, 2 and 6, 6 is parallel to the line passing through 0, -2 and 1, 0. Okay, so we need to find the slope of both lines. If we can show that their slopes are the same, then we know they're parallel. So for the first line, we have 6 minus 2 divided by 6 minus 4, using these first two points. 6 minus 2 is 4, and 6 minus 4 is 2. 4 divided by 2 is 2. So our first slope is 2. What about for our second line? Well, we'll use these 2 points, 0, 2, and 0, -2, and 1, 0. M2 is 0 minus a -2 divided by 1 minus 0. 0 minus a -2 is 0 plus 2, or 2. 1 minus 0 is 1, so our slope is 2. So, since our slopes are the same, M1 is equal to M2, the lines are parallel. Okay, let's now talk about lines that are perpendicular. Definition. Two lines that intersect at right angles, or 90 degrees, are said to be perpendicular. So slope and perpendicular lines. Here are some properties we get. If two non-vertical lines are perpendicular, let's write that on the next line. Then the product of their slopes is -1. In other words, if we take M1 times M2, we should get -1. Also, their slopes are called negative reciprocals. So if my slope for M1 was 3, then M2 would have to be negative 1/3 for it to be perpendicular. So if M1 was 3/5, then M2 would have to be negative 5/3. So you change the sign and you flip it. Okay? Another property we get is if the product of the slopes of the lines is -1, or they have negative reciprocal slopes, the lines are parallel. Sorry, not parallel, perpendicular. And finally, a horizontal line having 0 slope is perpendicular to a vertical line having undefined slope, and vice versa. Okay, let's do one last example. Example 4. Show that the line passing through -1, 4, and 3, 2 is perpendicular to the line passing through -2, -1, and 2, 7. Okay, so we need to show that their slopes are negative reciprocals, or that the slopes are equal to -1 when we multiply them together. So the slope of the first line using -1, 4, and 3, 2, we have 2 minus 4 divided by 3 minus a -1. 2 minus 4 is -2. 3 minus a -1 is the same as 3 plus 1, which is 4. That reduces, -2/4 reduces to -1/2. So the slope of my first line, M1, is -1/2. Let's find the slope of the second line using the points -2, -1, and 2, 7. So we have 7 minus a -1 divided by 2 minus a -2. 7 minus a -1 is the same as 7 plus 1, or 8. 2 minus a -2 is the same as 2 plus 2, which is 4. And 8 divided by 4 is 2. So M2 is equal to 2. Notice that we have -1/2. We can flip that to make it -2, change the sign to a +2, and we get the slope for line 2. If we start with line 2, we can flip it, make it a fraction, 2/1, flip it, and we get 1/2, and throw on a negative, and we get back to our original slope. So we know they're perpendicular, but let's multiply them together. So we get -1/2 for the first one times 2/1. That gives us -2/2, which is -1. Therefore, since M1 and M2 are negative reciprocals, that means that M1 times M2 is equal to -1. The two lines are perpendicular. Now, I want to pay particular emphasis to this. You really, really need to practice on being able to determine whether two slopes are perpendicular or not. You will probably see this in your homework and on your test. This is a place where I see students mess up a lot, is finding negative reciprocal slopes and being able to recognize whether a line is perpendicular to another line. That is the conclusion of section 3.3, slope. Good luck on your homework. Please let me know if you have any questions, and I'll see you in the